Good morning. As normal, it's Kuseko here. So I'm just going for electrostatic. Electrostatic. Speaking about electrostatic, guys, we have the 5 objectives that we need to cover for Form 5 electrostatics. Electrostatics. Statics. Speaking about electrostatics, we have the charge. You need to know about the electric charge. Electric charge. Concepts about electric charges. Charges. We need to know about the forces and the fields, forces and fields. You need to know about the potential, electrostatic potential, electric potential, electric potential, potential. Before you move anywhere, you just need to know what are the objectives that you need to learn in this topic. And finally, potential. So you need to know about the Gauss's law. Gauss's law, actually. And the fifth is about the capacitor. You need to describe about the capacitors. Okay. So I'm just going I'm just going to start with the electric charges. I'm going to speak just about the charges. Most of the students here think they know electrostatic, but they actually don't know about the charges. Kuna maswali mengi sana hapa ya charges, ambapo ni kama kwa mfano, kwa nini conductors they can't be charged by friction? Did you know that? For example, kikwambia a fire and silica are loved, which one will become positive and which one will become negative if the fire has the larger work function than the fire? Wakikuuliza maswali kwa mfano, so all questions about the charges, those conceptual questions, there are good conceptual questions here. Kwa mfano gari likiwa linakimbia wakati wa mvua, hashauriwi nandi passenger kushuka na kushika bodi ya gari, anaweza akajikuta amepata electrical shock. What's the reason? Kwa vitu kama hivyo tutaenda kuvijibu kwenye electric charge, ambapo watu wengi wanaruka hii form 5, mnaruka sana hii about that, those conceptual questions about just the charges, the methods of charging. Wengi hamjui methods of charging, mna assume kama mnajua kwamba it's contact, it's rubbing, it's induction, but you don't know in a positive, in a negative, how do we do material gani hayafanyi hii charging method na hii ya charging method hii. So I'm just going to elaborate for you very clearly, lakini pia kuna concepts nyingi hapa ambazo huwa hazifundishwi easily, lakini kwenye maswali yanatoka. So I just hope you're just going to be with me till the last video. I hope see you soon. Let me start with the electric charges. Let me start with the electric charges. Electric charges. Let me speak about the electric charges here. First thing, what is electrostatic? Before I just go anywhere. What is electrostatic? What is electrostatics? Speaking about electrostatics, hii tunaongelea ni stud. It's a branch of electricity. What's electricity? First thing, you need to know electricity. This is the study of electrons. Study of electrons. But iko na two branches. It can be electrostatics or it can be current electricity. This current electricity is the study of the charges in motion. Mic yangu nawaka? Yes, charges in motion. So the study, but of what? Charges in motion. Don't mix it with the electric current. Electric current is the charges moving for a given time. So this is the quantity. Electric current is different from current electricity. Current electricity is just the study now, but talking about electric current, this is the amount. I is represented by I, is the amount of charge moved for a given time. But speaking about the electrostatic, it is the study of accumulation of charges at a point, meaning charges are static, they do not move. So the study of accumulation of charges is what we call electrostatic. But the accumulation of charges, we call it static electricity. Yeah? We call it static electricity. So this is the study. But the accumulation, the study of accumulation of charges at a point. Not that bad. But the study of that is the study electrostatic. But the accumulation now, the amount of charges accumulated, we call it static electricity. Yeah? It's different from static electricity. Static electricity is the accumulated charges, amount of accumulated charges. How? Accumulated charges. That's what we can speak about the the static electricity. Yeah. So actually speaking about the static electricity, static electricity, this is the amount, and this current electricity is the amount, not the study. So the study is called the current electricity, and this is called electrostatics. Okay, we are just going to deal with electrostatics now. Let's start about the charges. What's about the electric charges? Part number 1A, electric charges. Na hapa tena wanafunzi wengi wanakosea. Speaking about electric charges is not a particle. Kuna wanafunzi wanasema it's a particle. Kai. It's not a particle. It's a property of a fundamental particle, meaning fundamental particles of atom can be electron, proton, or neutron. So speaking about the electric charge is the property of a fundamental particle of an atom. So the origin of the charge is coming from the fundamental particle, subatomic particles of the atom. So speaking about that, we say, actually, if we speak about the electric charge, is a property of fundamental particles, subatomic particles, which can give rise to forces in magnetic and electric fields. So when electrons or protons passes through the electric or magnetic field, will experiences the forces due to the property which is called electric charge. So this property of those particles can be either negative or positive. We call the types of charges. Types of charges can be, charges are the properties, not the particle. So which contained by the particle is a property contained by the particles, which can now give the rise to the forces. So we can have the positive or the property which is the negative. That's what we say about the types of the charges. But what is the origin of the charges? Origin of the charges actually is due to actually the atom. Let's speak about where this charge originated from. Origin of the charge. For real, we can just say atom is neutral. It's neutral. But you know what? Being neutral, when electron is removed from the atom starts to have a charge. Or when the electron is added to the atom now starts to have charges. So the origin of charge is due to transfer of electron. Get me clear? Protons are inside the nucleus, so it's difficult to move. They are not moved. Protons, this is the nucleus, they are inside, but electrons, they are outside. So the origin of the charge is the transfer of electrons. So when added, meaning that will be the negative charge. When adding electrons, that will be negative. When removing of electrons, this become positive. So speaking about the origin of the charge is due to transfer of electron, not the positive. We don't have the positive, the proton are held inside. The property of the protons is held inside. So when there is a removal, meaning we have the deficiency of electron, is what we can call the positive charge on the atom. So speaking about that, I don't expect to say, if they ask you some questions, for example, sample question, if I ask you, hey, how can I charge the object negatively? Or how can I charge the object positively? And you say is by adding the positive charges. Nothing like that. It is it is never happening like that. So we just say it's the removal of electron is where you can charge the object positively. That's the origin of the charges. Let's discuss about the methods of charging. No, the properties of charge before I just move anyway. Properties of charges. Let's discuss about the properties of charges. Actually, speaking about the properties of charges, of charges. So speaking about the properties of charges, charge, it can be quantized. Meaning, saying quantized, this means it have a specific infinity small number. That all the charges is the integral multiple of that charge, that amount. So for example, unaweza and that unity E is the 1.6 times 10 and negative 19 columns. So we just say kwamba charge, one charge, any charge, for example Q, is always the integral multiple of this electronic charge of the electron. So kwa mfano hata nina charge 100 columns, it should be the summation of this, meaning nikigawa charge ndogo kabisa ambayo nitaipata ni hii, siwezi kupata nusu ya hii. So this is the minimum, so all other charges are the integral multiple of this. That's why I say is quantized, has a specific small quantity, which all the charges is just the integral multiple of that quantity. That's why you say it is quantized. The other thing is conserved. We call the law of conservation. Charges are conserved. Meaning charges is never created or destroyed. It's always been transferred or gained. So we say charges can't be created or destroyed. But what happens is just the total, not this NB, total charges on isolated system is always constant. Yes. So the total charge in a isolated system is always remaining constant. Regardless, for example, if I charge this and this, kama hii ilikuwa na 5 columns and this have 10 columns, so when I charge this can take 7 columns, while this can, let's say, have the -3, but the total is 10. So we just always remain the total, the summation of here and here can be 10. It doesn't matter even if the charges can transfer here, from here to here. So when you sum up the total charge, you must get the constant number. So that's why we say the charges are conserved. The charges are conserved. The total amount of charges is always remaining the same. Okay. The other property is that the charges, like charges attracts themselves. The third one, like charges attracts, repairs. Why? Unlike attracts. That's what we say about the property of the charges. Number 4, we can say about the forces that they produce. They always obey the inverse square law. Charges produces what? The charges produces forces which obeys inverse square law. What does it mean? Inverse square law ni sheria ambayo force, if I have this charge here and the other charge here, the force experienced here, force F, depends on the distance of separation. So the force is inversely proportional to the square of their distance of separation. That's what we can say, one of the properties of the charges. Okay, so those are the properties of charges. How about let's speak about it. Let's speak about it. Let's speak about it. Let's speak about. Then, so let's speak about those are the properties of charges. We have just discussed. Let's discuss about the methods of charging. Methods of charging. You really know about there are 3 methods of charging. One is about the friction. Friction, or we call it rubbing, by rubbing. You know there is what we call, instead of rubbing, you have what we call conduction or contact. Things comes in contact, the charge are transferred. The other thing is the number 3 is about the induction method. So there are 3 methods of charging bodies. So you critically have to know each one and how can you use it in your environment. What material are preferred and what are not preferred. So let's speak about the friction. 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 What happens to the friction? So friction is the method of charging by which 2 bodies are rubbed against each other. So bodies are rubbed against each other. But you need to know that this method is not preferred for the it's not preferred for conductors, because when you hold these two materials and you rub against them, conductors always transfer the electrons. So the electrons which can be generated here can be transferred through my hand toward the earth. So this can be discharged as I hold it. So it's only applicable for conductors when you have attached itself with the insulator, so that the charge should remain there, because we're talking about the accumulation of discharges. Let me go first, urinate. So we just continue with our session. What is this now? Okay, so speak about the friction now. Just the bodies are rubbed against each other, but it's not preferred for the conductors, because of the conduction. So conductors always takes the electrons away. It's not preferred for conductors unless holded by insulators. So when rubbing the conductors, you need to hold them by insulators so that electrons may not be transferred away but may accumulate, so as we may charge out the conductors. But this process of rubbing, there is a term we call triboelectricity. Triboelectricity. This is just the method. It's the method or process of charging bodies, or process by which the bodies tends to acquire the charges when rubbed against each other. Rubbed against each other. So this method of rubbing sometimes can be called triboelectricity. Triboelectricity. Yeah, but there is a triboelectric series. Triboelectric series is just the arrangement of triboelectric series is the arrangement of materials depending on their easiness to acquire the charges when rubbed against each other. Eh? So there are materials when rubbed against each other, they are easily gaining electrons than the other. And the one which is gaining more easily electrons has the low has the largest work function. What's the work function? You learned it in modern physics. Work function is the ability now of the method or a material to hold its electrons. The work function. You just studied in a photoelectric emission. When light is just illuminated on a metal, electrons tends to go away. If only that light has the energy equal to or greater than the work function of that surface. Now the work function is the energy to hold those electrons. So speaking about the triboelectric series, is now the arrangement of material due to the easiness of gaining the electrons. So this easiness depends on the work function of the surface or the material. So if this has the larger work function than this, electrons will just be attached to this. So when I love these two things, electrons will shift from this one to this one because this one has the largest work function than this one. So electrons will always be used by the object which has the lowest work function. So speaking about the triboelectric series, is the arrangement. It's the arrangement of materials depending on their easiness to acquire electrons. So we just speak about that. That's about the triboelectric series. So that's about the friction. Let's speak about things like that's about the friction. So questions like let me give you sample questions like questions like about the friction. Now it's about let me have a book here. For example, when a glass rod is rubbed against the silky cloth, some electrons from the glass attach themselves to the silk. Consequently, what happens? Do you get that? Let me write that question here. Sample questions. Sample questions about the just charging by friction. Sample questions. Sample questions. Sample questions. For example, explain. Let me say here. Explain. Let's say why electrons go from glass to silk and not from far to ebonite. Why electrons go from glass to silk and not from far to what? Ebonite. Why? Can you explain about that? The reason is work function. Whenever they ask you questions about why electrons should move, the direction of electrons, which body can acquire, you just look to the work functions. So the reason is the electrons goes from glass to silk because glass hints have small work function than silk. Do you see? But than silk. But also not from far to ebonite. meaning the ebonite has the largest work function, has the lowest work function. So ebonite sawa has the small work function. That's why he can't acquire the electrons more than the far when labbed. So, but work function, but far have the lowest work function, has the largest, work function. So always electrons will flow from the one with the smaller work function to direction will be to the one with the larger, who has the ability to hold the electrons work function. That's what happens. Another question is, for example, you can be asking, conductors cannot be electrified by friction. Why? Conductors can't be electrified by friction. So what happens? What happens if conductors can't be electrified by friction? Why? Explain why. Why conductors can't be electrified by so explain why. The reason is conductors takes away the electrons. That's why conductors can't be charged by friction. Is conductors takes away electrons from the area labbed. So through or conducts electrons through the hand of the palm of the hand, through the palm of the hand to the earth or ground. That's what we say, and that's why when charging, you need to wear an insulator, so as electrons should be just accumulated on the conductor. That's what we speak. Let's discuss about the charging by induction. Let's see charging by induction. Charging by induction. Okay. Let's speak about charging by induction. By induction. Charging by induction. What happens to the induction? Induction is when two bodies are not in contact, but they are charged. So charging when two bodies are not in contact, not in contact, but nearby each other. So this you can charge it either positively or you can charge it either negatively. So it depends. For example, now if you are charging by induction, you take, for example, this is the sentinel rod positive. If you are charging by, get me clear. If you are charging by induction, this means you need to use the opposite charge, NB. Opposite charge the body is used to charge the other body. For example, if I want to charge a body positive, so I just use the negative charges. Negative charged the body. So if this is the body, you need to put it on in the insulator so that it may not conduct away the electrons. So this is the insulator. This is the insulator. So I need to charge this. So I just take the negative nearby this body. So this is body A and this is body B. So talking about this means what happens, this negative here causes the repulsion to the negative charges on this body. So the negative will just shift here while here remains positive. So what happens exactly is finally you F it. So Fing it, these electrons will just flow toward the ground. So what remains here is the negative charges on this body, but having also the positive charges. Thus, you have charged the positive charge. But get me clear, when charging the negative, you want to change the body negatively, you use the positive charge, oppositely charge the body. So for example now, I want to charge this negatively. What happens? See here, see here, see here. This is my body now. I want to charge it negatively. Negatively. What do? I just use the positive. I just use the positive. So as the electrons are attracted to this side. So here remains the positive now. So what happens? I need, this is neutral now. Here, this way, B is neutral now. This is, I've just put it, the positive nearby, positive. So the positive tends to attract the electrons this side. As it attracts the electrons this side, I just F it. On Fing now, I just pull the electrons because this side has just remained the positive. So electrons tends to come up. It's opposite, yeah? So electrons comes up to neutralize this. I told you, remember that positive doesn't move. The positive doesn't move. Don't explain that you F it, then the positive goes to the ground. What the fuck is that? Never try to explain about that. Never. The positive charge is not moving. Whenever we say this is a positive, meaning there is a deficiency of electrons. Whenever we say it is negative, this means there is excess electrons. You get me? Never say that the positive were moving to the F. Fuck about that point. So we say this comes to neutralize here. So we continue to have the positive, but we just have the excess now, excess negative. That's what we say, charging negatively the body by induction. Let's speak about it. Mama. Let's speak about the charging by by contact. By contact. By contact. By contact. Let's speak about by contact. Let's speak about charging by contact. So speaking about charging by contact or conduction method, this is suitable for conductors. Very suitable for conductors. When two bodies are just in contact, exact contact. Two bodies are in contact. So this is the method of charging whereby two bodies becomes in contact. But what happens is that this is very good or suitable for conductors. Why? Because they allow the movement now of electrons. They conduct electrons. So we just say now it's different from rubbing. Rubbing is suitable for these insulators. And it's not good for insulators because electrons can't be transferred. So let's speak about the contact now method. Is actually you can charge it positively or you can charge it negatively. So it's different here. On charging by friction, no, by contact, you use the charge that you are charging. If you want to charge the body negative, you use the negative because electrons now are being transferred. They are not induced, they are transferred. So charging by contact, you use the object with the same charge that you want to produce on the other object that you are charging. So there is a big difference here. On induction, you use the opposite charge so as they may repel, and then you earth it. But on charging by contact, you just use the same charge sign. So charging by contact positively, meaning I should use the positive charge, NB. Same charged body is used. So whenever I charge, let's say I want to charge this positively, this is the insulator here you use. So this is the object that I want to charge, then I just use the positive. So what happens here is that this, when comes in contact, what happens here is electrons are pulled here. So electrons shift to this object, while this object tends to remain positive here. So they come and neutralize here. So final, I just have this object positive. That's what happened. This is insulator. This is insulator. So that's what happens. Huh? Don't hold direct because the electrons will be transferred. This is my contact method, and these are conductors are suitable in this case. So let's speak about the if I want to charge it negative, I just use the negative charge. I just use the negative charge. For example, now I can have now this one as the positive as it was. So I can just use, for example, in negative now, charging negatively. What happens? You use the negative. So just use the negative to charge is neutral. That's first. The second thing is just the negative now electrons has been shifted to the object now here. So that's negative. But also finally now the charge will be shifted to that side. What happens is electrons will just repel. Electrons will repel. So electrons as they shift, while this side remains the positive, you F it now. I want to charge it negative. So electrons will just be shifted, to the other object, will be transferred to the other object. That's what happens. That's what happens. That's what happens. So the negative charges will be pulled by the positive charges around. So that's what happens in by the contact method. So something to note here, which students never note about unless told, is that when charging by induction, you use the opposite charged body, but charging by conduction, you use the same charge. So charging by conduction, NEB, rate note is charging by induction, you use opposite charged body. But charging by friction, by contact, you use the same charged sign, same charged body. If it's positive to positive, if it's positive to positive, if it's negative to negative. But here, positive to negative or negative to positive. That's what happens. Okay, so that's about the electric charge. But we need to know, because the electric charge is now the introduction to electrostatics, what are the uses of electrostatic knowledge? Uses for electrostatic knowledge. Let's discuss about the uses now. The uses or the importances of or the applications of electrostatic. How is the application? Is electrostatic applicable? This knowledge, the start of the accumulation of charges. How is it applicable? So applications of electrostatics. What is electrostatics actually? The start of accumulation of charges, or the application of accumulation of charges. Yes. So what are the applications? What are the real life applications? The first thing, we use electrostatics in painting. Electrostatic spraying or painting. What happens here is you find a car, unakuta wale wanapaka rangi ya gari, kizungushe hivi, ile rangi inaenda inapiga pale kwenye bodi ili kupunguza upotevu wa rangi. Gari inakuwa charged positively, alafu rangi huwa inakuwa negatively charged. What happens ni kwamba zile wanapotupa hivi, anakiwa anazungusha hivi, ile rangi inaenda na ijipiga pale, inanasa kwa sababu ya electrostatic charging ambayo imefanywa positive, alafu ink inakuwa negative. So what happens ni kwamba ile haitaenda, hata kama imepita pembeni hapo, inavutwa ink. Kwa hiyo maana yake to reduce the wastage of paint of the spray or the ink, we just charge it positively and the ink is charged negatively, so as to reduce it, to combine easily to reduce the wastage of paint. The other thing is about the electrostatic generators. Electrostatic generator is like Van der Graaf. We shall study it in potential. Wakati tutafanya potential. Van der Graaf. Van der Graaf. So this generator is the one of the generators that generates very large potential due to sharp points, the knowledge of the sharp points, the presence of the sharp points at a point. So there is the accumulation of the charges in the sharp points, so we generate the larger potential. So these generators are used to generate larger potential. So that's knowledge of generating the larger potential is depending on the study of electrostatics. So we call it generating very larger potential. This potential now can just be used in some other activities, generating the energies and what. So another uses of electrostatics, even in computers, computer keys, the keyboards. What happens to the keyboards? Keyboards of the computer, computer. Those keys contains the capacitors. Keys contains capacitors below them. Capacitors below them. So when clicking the key, this means you reduce either the area or the distance of separation between the plates. So you tend to change the capacitances, and so it is translated as the changes in the current, and so the computer can just sense that which letter has been pressed. So for example, I just have here my laptop. For example, here I just have my laptop here. When I click, let me try. For example, when I click this button T, do you see? So this is the capacitor inside. So I just reduce either the area or the distance of separation between the plates of the capacitor. So it is sensed as it's just sensed like the change in current in some keys. So that the computer can just translate. The fourth thing is about let's say about the one of the application also is about the electrostatic precipitators. Electrostatic precipitators. Precipitators. Najua bana, this electrostatic precipitators is actually the system by which the waste gases tends to pass through those pipes. They contains wires and plates. So when the waste gases passes, they tend to attract those particles and those harmful particles and allow just the gases to pass through. So these electrostatic precipitators are used in industries that tends to produce the smokes. So they attract they are made, which contains these precipitators. They are pipes made of plates and wires. So when the gases passes here, gases passing out, what happens? Those particles which are unharmful, they just attracted here because this is made positive. The plates and the wires are made positive, so as the gases are all are negative. So when passing through here, they are just attracted, and the pure gas without those particles, harmful particles, they just pass out. That's what we can say about the electrostatic precipitators. They are pipes that can just remove the unharmful the harmful particles. Number five. Number five. One of the application is just, for example, you can have the laser printers. Laser printers tends to have drums and the ink. So the drum where the paper comes is positive and the ink is negative. So when the ink falls on the paper, they just attract on that area which has been illuminated by the razor. So we just say razor printers, razor printers. What happens to the razor printers? What happens to razor printers? To razor printers. What happens to razor printers? Razor printers. Look here. Speaking about the razor printers, they tend to be like this. They have the drums where the paper paper are pressed. So actually the lasers tends to illuminate, to translate the words that has been set on the computer. So they tend to put the patterns. But the ink, when thrown the ink here, ink tends, because this is positive, the ink is negative. It's just sticking on the illuminated areas only. So that's what we use in eraser printer. We use the knowledge of electrostatic so as to print the materials. Okay, that's what we speak about the applications of electrostatic. Okay, that's the first video. That's the first part, the electric charges. So we have just spoken about really charges. So the basic concepts like the properties of charges, the type C, what is about the electricity, actually electrostatic, current electricity. You never mix about the current electricity and electric current. So those are the terms we discussed, the properties of the charges. What are the charges? We discussed about the applications now and the methods of charging. Okay, God damn, see you guys in fields and forces. It's Kuseko, your boy. I'm signing out.